Yeah, it's super bad news for me because I missed the party last night and I'm so jealous. But don't be judgmental if I mess up things. I really prepared this talk last night. I'm JBD, as Julius mentioned. I work at Google, mainly on the instrumentation side of the thing. So I don't understand everything end to end, but I understand my stuff. If you have questions, I may need to reroute you to the right people if I don't know anything about it. So today's talk is about RPC metrics. And to be honest, RPC is just basically gRPC at Google now, pretty much. So it's going to be more about gRPC metrics. But if you don't like gRPC, that's fine because these concepts work regardless of the protocol. So you can see it as a talk on request metrics. So why do we care about metrics is the first question, I think, because we care about availability. And, we as an industry like to trivialize and, use simple descriptions of what availability is. This is our VP of SRE on reliability. 100% is the wrong reliability target basically for anything. Just because 100% just doesn't exist. It's so complex and expensive to achieve 100% that it's not practical to set it as a goal, and it's not achievable at all. So maybe we should try to understand what is good availability, what is good reliability, or let's ask first what is availability to begin with. So we see availability is about whether a service is performing as user expects or not. In simpler terms, we say that like a service is available if users cannot tell there was an outage. So failure can happen and might happen, but it should be rare enough. And rare enough here is just really depends on the business, how much your users can tolerate failure and so on. So you need to set your, failure. It depends on the system. So I just want to reiterate, the key here is not like 100% reliability because it's, just not possible. We have more of a principled way of saying things like, what is the level of downtime which is acceptable for our service. Lots of people have mentioned, SLAs, SLIs, SLOs. So we define and use this. We have this common language all across the organization. We write several objectives to tell everybody, hey, this is, what is acceptable downtime. And there are two major categories we care about, RPC especially, but you can add more indicators to your SLOs. The first one is about, the error rate, how much, error I can tolerate. What I mean by error here is more like, hey, this, some sort of like HTTP 500, like, hey, this crashed and, I'm not getting anything. The second one is the latency. We just want to have some acceptance latency boundaries. You can say, hey, I want 99.99% of the time. I'm going to tell you this method is going to return in less than 100 milliseconds. So it's kind of like setting those boundaries. And if we are going outside of those boundaries, there's an SLO violation. So measuring and alerting on RPC metrics in an effective way in a distributed system is very hard. That's why, it's just like you have all these different layers of infrastructure in a large company. And this is an everyday architectural diagram. We usually end up like having this big, business-heavy logic front-end server that depends on different layers. And at some point, everybody is dependent on common infrastructure layers like the storage systems like Spanner and Blobstore. So things are getting a little bit nastier here because, since the entire company is dependent on the storage systems, it's just harder for this team to analyze their metrics. It's hard for them to understand the root cause of, outages, break down their data if there's not enough, cardinality. They cannot like easily tell like, hey, who is, breaking this API because they were misusing the API easily if they don't have enough dimensions. So our infrastructure teams often want to ask like questions like this. Hey, are we meeting the SLO for this particular other team or particular other customer? And what is the impact of infra? What is the impact of a product on our infra. So we can actually say that like, hey, this product is feasible or profitable or not. And the other one, like how much do we need to scale up if this product grows 10% overnight? So we can do some planning maybe, and we can see if it's feasible, if we actually have means of computing power to support that growth. So this is why we basically want to have more high cardinality and multidimensional data. Then we can filter, group by things, and like cross compare to understand what is going on. But in the end of the day, I just want to query stuff like this. I just want latency distribution of RPCs, originated at Google Analytics maybe, and I just want to see the request that took this much for this customer. Compare the request latency initiated at web versus front end, so I can see the user's experience in different front ends. So the complicated part of it is just like the entire promise of our microservices architecture is we just don't want any tight coupling between things. And if we want to have high dimensions, what does this mean for the lower ends of the stack? How can a low-level service such as Blobstore in this case knows about these dimensions and record data with those dimensions? This is why this is why we label things by propagating labels all across. So we produce some labels at the higher level services like the analytics front-end server, for example, and then we pass it as a part of the RPC all across the stack, so the lower ends of the stack can use these labels when they're recording metrics. In this case, there's an example label. It's an originator. Originator is it's been generated at the first place that RPC is starting, and then nothing is mutating it all across. They just pass it if it exists. So when you are recording metrics at the low end, you actually know that like originator was the analytics. So this is, by the way, this is a mini setup, a conceptual dashboard, not a real one. It looks like a toy because it's a toy. This is a breakdown of the Blobstore read RPC errors by originator service. So you can see, Spanner itself is directly creating a lot of errors. Some of the other services are also, seeing some errors, and they're most likely going through, Spanner or other DBs. But you can actually see, the Spanner is just directly having this number of error count. So now I will actually focus a little bit more on the concepts that I haven't seen elsewhere in my 10-year career before coming to Google. And these are like my favorite ones. Like there are even more. I think I will try to do my best to capture a few of those. So we have an interesting story when it comes to metric collection. We split aggregation from recording things. So this means we had two different APIs. The first API is the recording API. The other API is setting up aggregations on what is being recorded. This means that you can set up aggregations in runtime, and as well as in production. For example, we have this high-level concept of a measure handle. You can just record values on different measures. And what you do is, at any time, you can set an aggregation on that measure, broken down with a set of labels, label keys, and export data. Start aggregation and exporting data. So this is very interesting because if you have a production issue and if you want to understand maybe more, you can push dynamically new aggregations or expand an existing aggregation and gather more data, and then disable it once you are done. Because it might be an expensive thing to aggregate, but at least in order to respond to an incident, you can just dynamically change the aggregation. Designing what to monitor is very hard, and I think this is why we encourage a model where we have this flexibility to dynamically expand what we aggregate and collect. and disable non-essential things when things are not needed anymore. Exemplars is an entirely new piece of technology at Google, and most recently we started to do a better job internally, like associating metrics with other signals, such as distributed traces. For example, here there's a dashboard. Each latency, this is a heat map, latency heat map. For each latency bucket, we collect some example traces. If the trace is sampled in the critical path, if there's a sample trace in the critical path, and our dashboard now can display this stuff. And if there's a problem, hey, there's this like super high latency issue, people can just click on and like see an example trace and like further dig and like see what actually happened. This was a lot of it's a lot of it's a big issue if you want to do this manually. Like, hey, you need to go and like query your tracing backend to have a sample. And this is more like smooth. Hey, I just need an example, and you can see the distributed trace. And one of the other useful tools is like we have these pages, introspection pages. These are, I don't know if you are any familiar, but these are little pages that is served from all servers at Google. And they're just small, dashboards. They are only responsible for anything collected in the current process, and visualizes them and allows you to see what is going on. It's a good tool. Some people who have never used these tools actually just don't understand how useful they are. It's a very good tool during development time, but I think more importantly, if you have an issue exporting data to your actual backend, to your monitoring backend, you can see what is going on by looking at these pages. We provide several pages for RPC stats and so on, but we also have like a tracing, for example, dashboard. You can see, hey, this request has failed. We want to export to, for example, Monarch, but it's consistently failing because there's the error message there, and you can easily debug things without having to depend on an actual backend. And it's useful, and it's kind of like a true last resort. So it's important. This is what it looks like. So CSS is not a skill that we are highly invested in. So our pages are just okay, but this is our PCS page. So in this process, I'm making a bunch of pops up RPCs. They're all outgoing. This is not a server. It was just like a command line tool. But I also exposed an RPCs page by starting a server, because why not? You can see the count, RPC count, latency, rate, input, output, like payload sizes, and that type of stuff, and like error counts, of course. So what about exporting the backends, and what about Prometheus? We use Monarch. It's our new, globally distributed monitoring service. It's quite different than Borgmon, to be honest, in various ways, as well as exposition format. To be honest, a huge portion of our infrastructure is actually like living in the open. And, we're building more things in open. Lots of other companies are also dependent on our, infrastructure, open source infrastructure. And these people don't have any access to Monarch, so we cannot instrument things just with Monarch. And, generally speaking, Google Cloud customers love Prometheus, use Prometheus. It's a huge ecosystem that we cannot just ignore. So we like to instrument things the way we like, and we have our specific backends. But in the end of the day, we just want to give people the opportunity to export all these platform metrics, or the framework metrics, or the client library metrics to Prometheus as well. That's why we started write these instrumentation layers that is a little bit backend agnostic, so you can send stuff. See the data in Prometheus as well. For example, this is an example of our client libraries. This is a proprietary API. Our PubSub API is a Google Cloud Platform API. There's a library for that, which is this the Go library is cloudgoogle.com, Go PubSub, and it's exposing some counters. If you go get this and like set up things, you can actually like, export the pool count, stream related things, the number of acknowledged stuff, the number of non-acknowledged stuff, and more. And we also provide the RPC metrics, so you can, export a lot of those custom counters as well as RPC metrics from the client library and see things in Prometheus. So last but not the least, few hours later, I think we will announce that we are happy to be collaborating on open metrics. So I'm spoiling it right now. We've been already collaborating it, but we were trying to make it as a first class export format for our core instrumentation libraries in the long term. Sorry for spoiling it. I actually need to ask my company if it's okay for me to talk about this and not get fired. And they said, yeah, I mean. So Richard is the next speaker. He should be the one talking about this. So I really like that, it's a collaboration effort between a lot of parties and we are a part of it. I think I have done a good job, connecting my talk to the next one. So I just want to say thank you so much. I can have questions if you have any.
Thank you so much. We have like 10 minutes for questions.
Dashboard looks interesting. What is it something written by
the
Google?
Minitoid dashboard?
A dashboard with where you can put this distribute and trace. Yeah.
Oh, this is actually a stack driver. I mean, we have something similar internal, which is different. It's just a heap map from stack driver. Yeah. Yeah, it's.
Hello. So I've read the SRE book, and I'm glad you're up there. And I've always had this question, and I think they had a chapter on capacity planning. How do you go about that with teams that have no idea about doing that or monitoring?
Yeah. There's actually a team that is like entirely like focused on this. They are not just doing like some consultancy, but they actually provide. They know what to look and how to look and like measure things. So there's always that team available for you to just go and learn. And it's just like basically, I think from my knowledge at least, like it works that way. It's more of like learning, and like there's some certain things that you can inherit. You're not starting from scratch, but it's just more of like the consultant's role, and they have tooling and so on, and they utilize some of the existing signals at least to give you a bunch of things already.
Hi there. So I recently had the experience of playing around with gRPC. Well, being an ex-Googler, it was quite easy to use it, Pro2C, whatever, it all works. But after I got it running, the first thing I missed was having an RPCZ page in there. And it was quite funny that like in this talk, you gave a screenshot of it. Is there an RPCZ equivalent in like the open source version of gRPC, or is
there's we have this client library, instrumentation project at Google called Census. We are also maintaining that RPC's page, and we're sort of like open sourcing it. So there is actually a open source version of it. It's not entirely super complete in all these different languages. So I didn't want to like go and like talk about that project a lot. I think it requires a little bit more, work. But we are open sourcing that stack, and we want to reuse the open source version internally as well. So RPCs is going to be served by the new open source version of the implementation. And I think that like in 6 months or something that we will have better support all across different languages to support RPCs and stats and traces.
Yeah, thank you for the talk. I was just curious how you gather RPC metrics. Are they emitted from the clients, or do you have a proxy, in the open source world, this might be Envoy, that's responsible for emitting kind of these standardized metrics?
So we usually like two scenarios. If there's a sidecar, we're trying to utilize sidecar, try to generate request metrics from the sidecar. If there's no sidecar, we by default are trying to utilize framework integrations. In that case, I was just dependent on the client libraries were just dependent on gRPC integration. So as soon as you just pull it in, and the client libraries are pulling it in, we just generate our RPC stats. We don't encourage people to think about RPC stats themselves. It needs to be coming to you from framework integrations or sidecars. And if you want to add like custom stuff, yeah, just use the low-level APIs. But otherwise, you shouldn't be doing it.
Anyone? Okay.
All right.
Thank
Thank you
you.
so much. Yeah, thanks.